the data. We want to generate the result. So that based on this analysis of data, we want to arrive at a conclusion. So that they are answered, these conclusions will answer our research question. Whatever research questions we state, they are met. So that is the whole process of this research process. So we have already collected the data. Data is at home with us. So we start analysis. Usually it is stated that when you collect the data, design a study, collect the data, number will speak for themselves. But as a statistician, we don't do. Number do not speak for themselves. Numbers speak for themselves only when you properly state your research objectives, you state your research question, design your study, collect the data, and answer it by analyzing the statistical data through descriptive and inferential statistics. So when we carry out our data analysis, our focus on these two main branches of statistics, that is generating the descriptive statistics and testing the hypothesis, and they are confirmed or refuted through inferential statistics. So thus, in a nutshell, the main objective of data analysis, which we want to generate our results through data analysis, is to answer the research question. We have started our research question by stating the research question. So these research questions have to be answered. Or if you have set aims and objective, this aims and objective has to be met. If you are conducting a experimental study or analytical study, we have hypothesis. We have stated our research hypothesis. So this research hypothesis has to be either confirmed or refuted. So how all these tasks are achieved? Mainly all these tasks are achieved through generating descriptive statistics and inferential statistics. As we are aware that descriptive statistics refer to describing the basic features of the data we collect. Mainly it describes the background characteristics of our subjects. Though generating a descriptive statistics may not be your objective, you may have, if you are conducting an analytical study or experimental study, testing the hypothesis is your main objective. But even then, you have to generate the descriptive statistics in order to generalize this, about whom these conclusions are hold, like about whom this conclusion can be generalized. What are their subject? What are their background characters? So before starting our actual analysis, we have to generate our descriptive statistics to understand about whom these conclusions are applicable. So mainly while generating the descriptive statistics, we generate tables, graphs, summarize the data in terms of measures of central tendency and measures of dispersion, such as mean plus or minus standard deviation or median plus or minus interquartile rate. Okay. So these are the main features of generating a descriptive statistics. But whole process of inferential statistics also includes whatever sample results, sample statistics, sample descriptive statistics we got, about which we want to generalize the conclusion. Means whatever sample results we got, whether they are applicable to larger population or. Okay. So then coming to the inferential statistics. So inferential statistics, mainly it is a process of making inference or conclusion about the target population based on sample. You might be aware that we want to answer a research question about a specific population or a target population, but we are not collecting this information from entire target population. We are collecting information from the sample, representative sample, mainly a random sample. So whatever results we got from this random sample, we want to make sure that they are applicable to target. So mainly this task of inferential statistics include two aspects, estimation and testing of hypothesis. So you have collected the data, mainly a sample data using any of the random sampling methods. So after following this sampling methods, you collect the measurements, whatever measurement you made, we estimate. We want to get the estimate of these parameters. So when we go for this inferential statistics, you should be able to distinguish between these two terminologies, parameter and statistic. Parameter refers to the measurement which belongs to your entire target population. Whereas statistic refers to measurements or estimate based on our samples. Let us say, for example, in a certain locality, we want to estimate the per capita income of the household. So this entire area, in this geographical area, it may be a subdivisional area or it may be a district. So this entire district population refers to a population. Whereas in order to estimate what we do, we select some 500 or 1000 households. So based on these households, we estimate the per capita income. And based on this, we say the per capita income of this household is monthly household income, average household income is rupees 50,000, 60,000, etc. So this is one part of estimation. So estimation has two aspects here, point estimation and interval estimation. Point estimation refers to exact value, single value. Since we are estimating the sample values based on the sample, it is not possible to give exact estimate of the target population. So we want to true range in which this population parameters are lying. For that, we estimate interval estimates. So usually we talk of 95% confidence interval. So this 95% confidence interval gives, we are 95% sure that the true value will lie between these two values, lower limit and upper. This is one aspect of inferential. Second aspect is testing of hypothesis. So testing of hypothesis refers to we have stated our hypothesis, we want to confirm it or refute it. Say for example, a marketing company may be interested to know whether its product is popular in urban area or rural area. Suppose the company has two products, product A and product A. So based on the prior studies, prior estimation, they are of the opinion that product A is more popular in rural area and product B is more popular in urban area. So that they want to test it, whether what the findings they found it on these samples, it really exists in the target population also, so that accordingly they can plan their production process. So this is about testing of hypothesis. The most common example of inference, statistical inference, is related to clinical. Since now we are in the grip of this parliamentary election now, there are many news channels are predicting which party will come to the power and how many seats they will get. So this is all based on this inferential statistics. They take a representative sample from each of the parliamentary constituencies and select the samples. Based on their sample information, they estimate party A will get how many seats, party B will get how many seats. So this whole entire process is we can refer it as an inferential statistics. Okay, so before you start your data analysis, so you should know what type of study you are conducting. Is it your analysis is related to descriptive study or analytical study? Because in descriptive study, what we do, we describe the state of affairs. We don't go for comparison. Usually descriptive study is based on single group. Whereas in analytical study, we try to establish cause-effect relationship. It includes two or more groups. And this objective you should be very clear, so that what tables, what graphs to generate, and what different statistical tests you can use, so it will become clear. Then if you are going for an analytical study, which is there are dependent and independent variable, you have to identify what is your dependent variable, what is your independent variable, what is the scale of measurement. So accordingly, you can choose the various statistical tests. So when we go for a descriptive study, usually we describe the data in terms of number and percent for categorical data, mean plus or minus standard deviation for quantitative. If it is an analytical study based on our observation, we may go for a correlation study or we may go for association study between two categorical studies using chi-square test. We may go for predictions, use prediction of outcome using regression. We may compare two or more outcome treatments using the student detail, or ultimately in an analytical study, our focus of analysis is on finding the p-value, means whatever results difference between two outcomes or association between two or more variables, is it due to chance or not? That is the main focus of our data analysis. Okay. So how we analyze like this? What are our strategies to analyze this? First step in the data analysis is describing the background characteristics of your subject in terms of table and graph. Generate a table, say such as age group, gender, their education level, income level, exposure to various events or outcomes, etc. Okay, then you carry out the univariate or bias. Univariate means univariate or bias means there is only one dependent variable. Statistically, univariate analysis means we are comparing the outcome variable with respect to single outcome with respect to various independent variables. Multivariate analysis means we are considering more than one dependent variable simultaneously. So student t-test is a univariate analysis. Chi-square test is a bivariate analysis. We are considering the two categorical variables. So when we carry out the univariate test, our focus is on single variables. Suppose if you are conducting a study with say 15 variables, of which say 10 variables come statistically significant. These 10 variables we arrived using a chi-square test, student t-test, correlation, regression, etc. So when the individual variables are statistically significant, our ultimate objective is if we consider simultaneously how many of these variables are statistically independent influence on this one. Say for example, logistic regression. We can carry out chi-square test. The chi-square test may show association with many independent variables. But ultimately, we are interested to know which of the variables have independent variables. Sometimes the categorical variables, independent variables, they are related themselves internally. So which of these variables have independent influence on the outcome variables? We go for multivariate. So this is our approach in statistical analysis. So based on the statistical analysis, purpose, specific objectives, we go for chi-square test, correlation, regression, logistic regression, etc. Okay. So you have collected the data using a certain proforma. So there are various, this is an example of job satisfaction survey. There are various types of variables are there. So in order to start your data analysis, you should know what are these variables, how they are statistically measured, what is the data measurement scale. So you should have fair idea about data measurement scale. So this data measurement scale makes you very clear about which test you do. Suppose if you are finding the association between marital status and sex, both are categorical variable, you can use chi-square test. Okay. Suppose if you are finding the association between say age group and job satisfaction score. So you want to find, is there any job satisfaction score and age has any this. Usually it is said that at the beginning of the career, those who are young, they have lot of satisfaction is there. And as they work with the passage of time, with putting the more number of years, their job satisfaction decreases. So when both the variables are continuous, we can use correlation coefficient, Carl Pearson correlation coefficient to test the association. So based on the type of these variables, we decide which test to use, how to present it. Say for example, if you have to present your data for categorical data, we just present it in a cross table or simple bar diagram, multiple bar diagram. Whereas in continuous table like that, age, monthly income, etc., we use scatter diagram or we can use histogram. So based on your type of the data you are dealing, we go for various tasks accordingly. So mainly when we collect the data, in order to classify them, there are mainly 4 types of scales we are using data for measuring the data: nominal scale, ordinal scale, interval scale, and ratio scale. Nominal scale refers to we just count the data based on presence or absence of a particular character. Suppose if you collected a data about marital status in a certain community, you conducted a survey and you notice their marital status as either married or unmarried. There may be other this thing. Our focus, we try it as whether currently person is married or not. So this type of variable, we call it as a nominal. Just we classify based on presence or absence of this character. Then next is ordinal variable. Ordinal variable is same as nominal, but there is some ordering of the data. Say for example, in office we see there is a peon, clerk, manager, officer, managing director, chief executive officer, like that. So this sort of classification, we can call it as ordinal scale. Interval scale and ratio scale, they are all continuous variable. Temperature is the only variable which we call it as a interval scale because it has equal distance but no meaningful zero. Usually all measurements start from 0. Here 0 doesn't mean that absence of temperature. Means it is temperature can be negative. So 0 means it is it is not a meaningful 0. And it has a equal distance. Means what difference you find between 40 degrees centigrade to 60 degrees centigrade is same as 80 degrees centigrade to 100 degrees. So it has a equal distance, but has no mean. But whereas the ratio scale, it has equal distance and meaningful G. Height, weight, systolic BP, age, monthly income. So all these variables, we call it as ratio scale. It has equal distance, meaningful zero. Say, for example, after age of 30, if I ask you what is the increase in your height, if you say zero, there is no increase in your height. So it doesn't mean that absence, but there is no change in your height. So it is a meaningful zero. In this context, it is. So we can notice here that interval and ratio scales have a unit of measurement, certain unit of measurement, such as nominal and ordinal. They are not measuring scale, just we classify them. So further we classify this them as continuous and categorical. So interval and ratio scale falls under continuous scale, whereas nominal and ordinal scale falls under categorical scale. So categorical variable we call statistically discrete variable. Interval and ratio statistically we call it as continuous variable. Continuous variable can be, it can take exact value or it can take any value in fraction. Say for example, your height may be 164 centimeter or any innumerable values between 164 to 160. Whereas nominal and ordinal, it presumes if you express quantitatively, they take a exact weights like male and female. If you classify them and assign a numerical values, male and female, you can assign a value 1 for male and 2. So discrete value assumes exact value, pure value, whereas continuous value can be pure value as well as fractional. So these things you have to. And once you collect your data, so you can directly enter your data into master chart. You can prepare a master chart by entering into the software, or you can enter into an Excel sheet. Usually I advise all the researcher, as and when you start collecting the data, getting data at your hand, you prepare a Excel sheet and enter there, so that you have a lot of advantage in manipulation of data, coding, decoding, and all these things can be made. So how to enter it in Excel data? So this is take an example. So when you start your entering the data in the Excel sheet, how to enter it? First row is exclusively meant for naming of the variable. Name of all the variables should come in the. How to enter the data? Here column refers to the variable, row refers to number of observations belonging to one person. So ID number is one variable, company is another variable, age is another variable, sex, education, like whatever data you collected. So here variable, each of the characteristics, we call it as variable. So for each variable, you form a column, and for each row, it all information related to one person. And take care that when you are entering the data for categorical data, say for example, the person may belongs to company A or B. So this company is assigned numerically. We assigned a numerical value 1 for company A. If employee belongs to company A, we assign value 1. If employee belongs to company 2, company B, we assign a value 2. Similarly, sex, like if person is male, assign a value 1, 2. So like this, for all categorical values, you assign a numerical value. When you go for advanced analysis, especially for analysis of variance, correlation, regression, etc., what happens there? All this data requires to be entered numerically. If you enter it as male, female, like MF, the data won't accept. If you want to run a logistic regression, it won't run. It insists that it has to be decoded as numeric. So this is how you can enter it. Let us see how you can. Okay, before we see this one, assign a code for this one and write it down somewhere, like so that you are not get confused. For gender, may we assigned a value 1 for male and female groups, like case 1. If the subject belong to case group, assign a value 1, control 2. Similarly for employment status, person may be employed, unemployed, student, housewife. Accordingly, you assign these values and note it down. When you enter into the software, decode this one. Assign a value labels for these codes, like 1 to 8. Okay, now let us go to Excel sheet. Okay, I'll go to Excel sheet now, where I have entered the data. So you can see the Excel sheet, how to enter the data like that. In first row, exclusively, you start from the first row, first column. First row is exclusively meant for naming of the variable. ID number, age group, sex, religion, education, etc. Whatever variables are there, I have to enter, name them and enter. And make sure that each of this name of the variables are unique. We have to use it only once. Suppose age means, suppose if you are collecting the data of age of the subject, age of the father, age of the mother, all this has to be entered in a one row only. Age underscore year means there should not be any gap also. If there is any gap, you can use the underscore. Only underscore is a special characteristic allowed. Age underscore year, it refers to age of the subject. Suppose if you want to enter age of the father, age underscore father, another column. Next column is age underscore mother. So name of the age of the school of this, and name of the variable should be exclusively used only once only during the entire process. Suppose if you are conducting a follow-up study where you are measuring the weight, like weight at the baseline, weight after 3 months, 6 months, like that, you can say weight underscore baseline, weight underscore 3 months, weight underscore 6 months, like that you can generate the values. And entire data, make sure that your entire data, if it is a comparative study, suppose if you are comparing a mean score of male and female employees, so your all entire data should be in one sheet. Usually while collecting the data, what we do in Excel sheet, we store data belonging to male in one sheet, data belonging to female in another sheet. But when you are transporting into SPSS, your entire data should be in one sheet. And you have to identify the groups like that. Suppose like male and female. 1, 2, you have to assign the various schools like accordingly this. Suppose if you are comparing the mean height of male and female, like so all data has to be in one. And another care you have to take that when height, weight, and all these things are there, all should be, especially in continuous variable, all should be uniformly entered. Like height means it should not happen that some in inch, some in meter, and this. If any of the values are missing or not available, just keep blank like that. Don't put dash, dot, not available, missing, not applicable, etc. Otherwise, what happens when you transfer into SPSS? This data continuous variable is treated as categorical variable. It is not treated as a. So this is how you can prepare your data in Excel, and then you can transport into SPSS. So once your data is ready, you save it, give a file name, note down in which of the folder you saved this Excel file. Then you can go into the SPSS and you can transport. Okay, before transporting this, save and close the Excel. Okay, now I will come to SPSS and how to enter the data. As you are aware that SPSS is a popular and very user-friendly software for all faculties of knowledge. It may be a science, commerce, management, law, any faculty you consider, it is very helpful and easy to perform and generate your statistics. So this is when you invoke the SPSS software, this is the window which you say, this is called it as SPSS editor, like data editor. So window which you are seeing, it is the it looks like a spreadsheet, like typical spreadsheet like Excel. So in Excel sheet, you can carry out calculation in each of the cells, whereas in SPSS, it is exclusively meant for data entry. Okay. So you can see there are on this window, there are many in this window, there are many editor the functions. You can see that file, edit, file as it is, as usual, it is used for open and close this menu. Edit, apart from copy paste, we can insert the variable. Suppose if you generated a variable, afterwards you realize that one more variable has to be inserted between the existing variable, you can use it. Data mainly it is related to data properties of which you entered. Split file, select cases. Suppose if you want to analyze the data for male only, female only, or if you want to generate the random sample, analyze the data for the sample cases, so you can use this. Then transform is mainly it is for your data manipulation. Say for example, if you have collected the data about monthly income of the household, number of the persons in the household. So based on this information, you want to calculate their per capita income. After deriving the per capita income, based on their income level, you want to classify them as whether they belongs to low socioeconomic status, middle income status, or high economic status. So this sort of all data manipulation can be there. And changing of codes also, it can be made, or you can recode it. So all these things are available with this menu to transfer. Then most important menu in this SPSS is the analyzer. It is like your statistician. All data analysis tasks, statistical tasks are performed with the help of analyzer. So for example, generating the tables, frequency table, bivariate table, comparing mean, running a independent sample t-test, paired sample t-test, finding the correlation, generating a regression results, linear, logistic regression, running a non-parametric test. Various parametric, non-parametric test can be run with the help of SPSS. Also, it can be used to generate the graphs. Okay. At the bottom, you are seeing the two views, data view and variable. Data view is mainly used for entering the data. Suppose first column in your database, you want to have serial number of each of the persons, 1, 2, 3, 4, etc. So like, so this is mainly for entering the data. See, when you might have noticed that when I entered the values here, data 1, 2, 3, 4, the software gave on its own variable name VAR000. Software has created a variable with variable name 00. If you want a specific name for this one, so first column, you want to have serial number of the subject, second column, name. So in order to create this sort of database, we have to click on the variable view. So this variable we will give the information related to your variable which you are entering. So like that, first variable is serial number. So since I did not name it, so I entered the data, software give generated on its own. Suppose I want to change it, I can click on this cell. So I can say serial. Okay, don't use dot dash this one. Only special characteristic allowed is underscore. So first name of the variable, first variable in my database is serial number. Type means it is type of the data. So you can enter the data numeric, alphabet such as string. So by default, any variable we generated, the software generate type of the variable as numeric. If you want to change it, click here and change. If it is a numeric, it is serial number is there. Okay. Numeric. Width refers to how many width you want to allot. So width 8 with 2 decimal means this database allows 6-digit number with 2 fractions, 2 decimal places. So that is the meaning of width and this. So here label refers to, suppose while naming the name of the variable, we use the short form. Don't use a long name for naming of the variable. Suppose when you are generating the tables or when you are generating the descriptive table or graphs, you have to look at the name of the variable. If the name of the variable is very long, you will not be able to understand. So if we are given a short name, like up to 8 to 14 characteristic, if you are using a short names, you can, like you can say label is serial number of the subject. If you want to any details about this name of the variables. Next variable I want to have is name of the subject, name. Okay. So name is by default, it generated a numeric variable. Since Name of the persons are not numeric. We are not entering like other numbers. We are entering there alphabetically. So we have to change it. From numeric to, we have to change it to string. So other type of data we can enter is date. By date, what format we want to, we have to enter. Okay. How many characteristics in string? There are no decimal places. Width, like how many characteristics to hold the name of the person? You can say 30 to 35. So name of the person can be up to 35 characters. Decimal 0, name of the subject. Okay, values. Then next we want to enter age. Age of the subject, numeric. Okay, we don't require so many digits. We can have 4 decimal places. Next is sex of the person, gender. Like since we collected the data as male and female, we converted into numeric values by assigning a codes value 1 and 2. So here sex refer to gender of the person. And here values, you come to this cell values. So here what you have to do? You have to assign the values what you have. Value 1 we assigned for male. So we have to state that label, male. And we assigned a value 2 to female. Okay, when you add it, say okay. Next column we want to say for example, height. Height in centimeter. So we can write a height underscore centimeter. If you have any doubt about the unit of measurement, you can. Monthly income in rupees, dollar, pound, etc. Okay. And another important thing you should notice here is measure, like what type of data you are using. Say for example, height. Height is the ratio of a scale. It is measured on a ratio scale. It should be a scale. So we have to change to scale. Sex. It is a categorical data. So it is related to nominal data. So we can say the norm. Age is a continuous variable. It is measured on in ratio scale. We have to change into scale. Because when we generate the statistics, if the name of this variables are not properly specified, we want to say for example, if you want to run a student test to compare the height of the male and female subjects here, if height is stated as nominal or interval, this name of the variable won't be seen in the dependent variable. So dependent, in order to run a student test, your dependent variable should be continuous. Scale. If it is not scale, this variable you won't be able to see and it won't generate the statistics. Now come to this database here, data editor, and suppose name of the person is ABC, whose age is say 18 years, who is female, whose height is say 162 centimeter. Next person is PQR, whose age is say 20, who is female, who is male, whose height is 170 centimeter. The next person is XYZ. So write the name of the person. So it will hold up to 35 characters. If name of the subject is more than 35, it won't save there. Up to 35 characteristics only. So name of the next person is whose age is 19 years, who is male, whose height is 165 centimeter, like that you can. So once you generate your database, first thing you have to do, go to the file, save it. Save as. Give a file name to this one. Save as. Assign a file name for this student database or research database. And it has a file extension name .save. When you want to open it again, retrieve this file again. So you have to go to this file with the file extension .save. So .save has a file extension mainly for SPSS database. The data which you are inputting, which you have stored, is in the file with the file extension of dots. Okay, give a file name this, and then you start analysis. Suppose if you want to transform Excel to SPS. So first thing is before transporting it, know that in which folder you stored your Excel file, what is the name of this file. I have stored my Excel file in desktop. So in order to open it, what I will do, click on open, data, go to the folder where you stored your data. Desktop. Okay. Then what you have to do, you have to change file type from .save. .star.save is SPSS file. You have to change to Excel file. Okay. When you change file type from star.save to star.xls, you will see all the Excel. So my data is in the Excel file stat.xls. I have stored my data in XLS file with the file name star. So select that file, click open. Open. Okay, next thing it will ask in which of the worksheet your data is stored like. Because Excel can have many sheet like sheet 1, sheet 2, sheet 3. So in sheet 1, my data is there. I select the sheet 1, click OK. Okay. So whatever data which was there in Excel, it has come. I will show this SPSS file once again after transporting the SPSS. Okay, this is the SPSS file. Whatever I stored in Excel file, it has come now to SPS. Okay, so once it comes to SPSS, this one, first thing again, you save this file. Give a file name and save in the folder where you want to store. Okay, then next step is you come to the variable view, and for all the categorical variable, you assign the values, value labels. Sex, like suppose if you want to give the explanation about this one, like gender, sex is gender. One is male, two is female. Add like that. Okay, and so. So like this for all categorical variable. There is sex, religion, education, BMI group, DM, that is diabetes status. Okay, for all the categorical variable, you have to assign a values like, so that when you generate the table, it will show how many males and females are there. If you did not assign the values, what happens? You show the frequency of one, which shows the frequency of two. It doesn't say male and female. And another thing is just check for this measure. If they are all are continuous variable, you should see them as a scale line. Suppose while entering the data, if it is a continuous variable age, like age of the person, suppose by mistake you put a dot. Here what happens? Instead of scale, it becomes a nominal line. Okay, make sure that whatever data you entered is a correct. If it is a categorical data, it should be either nominal or ordinal. If it is a continuous data, measurable data such as age, height, weight, etc., it should be a scale. You have to make sure. So once you get this data, you can start generating the descriptive steps. Okay, I will use the other file for this SPSS. Okay, this is the SPSS database, which is complete correctly entered and which is named and all these things. All details are available for all the categorical variable. I have assigned the codes for education, religion, and all this thing, age group, etc. Okay. So when we generate the descriptive statistic, first step is we generate the tables followed by graph. Let us see now how to generate the table. Suppose we want to generate the table for age group, frequencies, single variable. Okay. Okay, you select the variable for which, suppose age group and sex. Click OK. So when you everything is correct, your OK button is clear to press it. Otherwise, it won't be clear. So it is clear means it is correct. Click OK. The result will be generated in the another sheet, output sheets, called as SPSS viewer, statistic viewer. So I will share the screen, output file, output window. So this star.save, what it is says, it is a data input data, and output data you will see in another window called as IBM SPSS statistics viewer output, which has a file extension of .sq. Okay. So age group, we have generated a frequency table here. And for sex. So in the under the frequency table, this one, these are the various age groups. 20 to 39, 40 to 59. Frequency. That is number of observations in the age group. 20 to 39 year, 40 to 59 year, 60 to 70. Percentage, 51%. There is a percentage is there, valid percent. You can see here, valid observation is total data we entered is 100. Nothing is missing. Observation is missing, values are 0. When there are missing values are 0, percentage and valid percentage are same. So while finding the percentage, it is obtained out of 100. Valid percentage, suppose if there are 10 values are missing, this valid percentage is obtained out of 90 for the available list. So this valid total of percentage and valid percentage won't be same if there are some values are missing. This is the cumulative below this. Below 39 years are 51%, below 59 years are 85 years. Cumulative, that is less than cumulative percent. Similarly for gender. Okay, this is a univariate table. Suppose if you want to generate a cross tab bivariate table, age sex distribution. So for that, click on statistics. Then click on cross tabs. Okay. So in this window, you will be seeing all the list of variables. All the list of variables in your database are available left side. Out of which you have to take which variable you want to be appear on the row, you have to take it as a row. So for example, age group, each of the age group like 20 to 39, 40 to 59 are there. I want to be seen in the rows. So I select this variable and get it here right side as a row. In the column, I want male and female sex. Okay. So in order to generate a bivariate or cross tab, what you have to do? Select one variable on row, one variable on the column. Usually independent variables are taken on row side and dependent variable are taken on the column. Click OK. This table is generated. Okay, you can see row side, each group. See, these are not in a presentable form. Don't just copy and paste into your research report. As per the format of the thesis requirement or journal, you prepare your tables. Prepare an outline manually in the Word and enter these values.